Now, I'm William Mongo, and I'll talk to you guys about the intelligent system for detecting breast cancer. Now, we will talk about the purpose of the system design and architecture, the design patterns used to implement the system, a brief demonstration, and further works that need to be done. Now, what is the purpose of the system? The breast cancer detection system allows the user to enter information gotten from a patient and determines whether the patient is cancer-free or not. Now, the system transmits user data through a TCP IP connection and gets a response from the server, which is displayed on the screen. Okay, now, remember, intelligent design does not keep people from stealing your ideas. Rather, it makes people want to steal them. So let's see how intelligent our design was. Now, the system functions on a peer-to-peer network. So each instance of the system can be used as a client and a server at the same time. So this means that there are two subsystems, a client subsystem and a server subsystem, and each runs simultaneously on a different thread. Now the client subsystem, these are the visible aspects or the visible sections of the system. So it has a client interface and client classes. So the client interface permits classes from the other subsystem to be able to connect or communicate with the client. And on the server subsystem, we also have the server interface. So the design patterns implemented were facade and bridge patterns. Like we saw earlier, the facade pattern reduces coupling. So it provides the interfaces through which all communication between the subsystems is possible. The bridge pattern will facilitate the expansion of this system in the future. For instance, looking at the diagnose tool. This diagnose tool will be able to be replaced with a fully functional, intelligent system in the future with no difficulty. Now, the demonstration. So at the moment, I have another instance of the system which is now running and it's in the same network as I am. Now, let's see how this works. So, username, password, login. Okay. Now let's put in some values. Okay. Now, let's look at the console first. So as per the logger, we see that we opened the login form and we started the server socket, which enables other clients around me to also be able to connect to me. Now, if I submit, okay, now I see info from the main, which we are seeing right now, trying to connect to the server, main connected to the server. At the same time, the client socket shows us that we are connected to the server. And here we see that we are getting info from the server and we are finally closing the client socket. So now let's see what is going on. In the client socket, like we saw down here in the console, we see client connected, which is from the client socket. So this shows that we were actually connected to a server right near us and getting info from server. Here, we are getting info here. So it shows that the client socket was fully operational. And now let's look at the diagnose tool. The diagnose tool here. So this diagnose tool is not used, but rather the diagnose tool of the server is used. So, but this is how the diagnose tool looks like. And this is the output. No, rather, this is the output we saw in the user interface. Now, let's go back to our presentation. Now, further works. What needs to be done from now? The implementation of a real intelligent detection algorithm to work in the diagnose tool class, just like we saw. And we also need a database creation. So we need to create a little database to store usernames and passwords of the user of the app. Now, we also need more data validation to help to make sure the user submits all the necessary info which will be needed to verify whether or not the patient has cancer. Now, conclusion, was this the great design or not? Would you steal this design? References, Oracle coding convention was used.